Hi everyone, welcome back to today's episode. I have to recollect what we showed in the last episode. If you remember, if you have gone through our video, you might remember that we had shown you the concept of using a transformer and then to show the effect of transformer action using two coils. And in that process, we showed you how you get alternating current and what is the nature of the curve of the alternating current. And then we proceeded to a rectifier, and then we proceeded to that we call the current, oscillating current, but it is not fully direct current. It is called pulsating DC, that also we have shown. Anyway, we have to brief you in the present session. Now, please get ready to see this transformer here. This very important item for your experimental table. What is there inside? I have already told, let me repeat. It has got a input which is connected to 230 volt AC, and the output, these two wires coming to our setup, is 15 volt AC, and this is producing alternating current. Our proof is here in the oscilloscope. The oscilloscope was already engaged to show our viewers that what is the nature of the alternating current. Those who have missed the previous program can see now. This is the oscillating current. This reference line is 0 line, then up and down, and then coming to 0. So, this is called starting from 0 to up, again to 0, then to minus and 0. This is called a full cycle. So, this is called a sine wave cycle, and this is called the probe through which we take the current for curving or graphing. Now, I remove these two probe points from the alternating point situation. Now, I request the camera is now focusing on this setup. This is called a rectifier component, and you might see through a camera it has got 4 terminals, 2 connected to your 15 volt AC. These are the 2 center terminals, and those 2 outside terminals are the output terminals. That means, your alternating current is corrected using this rectifier at these 2 points. So, how is this connection? Again I have to show you. So, I connect and you please see it. This is one probe and the other probe is connected to this point, and your duty is to observe the oscilloscope. This is called the pulsating DC. You might observe the curve never goes below the reference line. That means, negative part is cut. Only the positive portion is available on the scope. That means, we are sure this red is positive, this black is negative, but this is pulsating. And after that, we have to proceed again to power actually our transformer action. This coil, you remember, we last used reserving 2 terminals. What I am to do now, I will connect the red with red for your observation. And the black with black. Remember, somebody may object that why are you sir doing open naked handed and connecting by your hand, these are all electricity. But remember, this side is low voltage 15 volt. So, it is safe to operate or work with your hand. Now, connected, the secondary coil is here. This coil has got an iron core and that coil also has got an iron core, and I will place both together, and you are requested to see. I also hold it that the secondary coil induces some voltage which is getting to LED and LED is getting power. And now, that day we had a discussion, even though we had said direct current cannot induce, but here we show you pulsating direct current can induce. Now, one thing we have to do, this pulsating DC we have to rectify again to get almost DC. That means, whenever you are using a battery current, it is called the perfect DC, and then this is pulsating DC. Now, see the wave, I will show you again because I have already released. So, what I am doing, I will connect this setup, and this setup is called a capacitor bank. Here we have engaged 3 parallel combination of capacitors 1000 microfarad each. So, the resulting is 3000 microfarad, and it has got 2 terminals. Even though it is a combination of 3, the final combination is having 2 terminals, one positive, one in negative. So, this red I will connect here again. You have to please go through, and then black here again, and please go through that the induction process stops. LED cannot glow now. If I remove the capacitor bank, LED will glow because of induction. If I connect, the curve becomes almost DC. Now, that I want to show you. This is my target. How should I show it? So, what I have to do? I have to connect and then finally, I have to show it. So, what I have to connect? Capacitor point connected to this, and then negative connected to the negative. Induction stops, and now our duty is almost DC, even though it is not pure straight line, and that is why the induction stops and the LED does not glow. So, this is a setup we require at home, and the setup is like that. I have to summarize. You need a transformer, you need a rectifier, you need a capacitor bank, and then your output will be almost similar to a battery current, and you can use it for your experimental purposes. So, thank you all. I do not know how was the system. You have to go through our video and suggest us for further improvement in future programs. We meet next.